Hi students, today we are going to start a new unit, optics. You all know what is optics, isn't it? It is a branch of physics which mainly deals with how light is produced, how light propagates through a medium, and what is the nature of light in different medium. So based on how light is produced and how light propagates and its nature, optics has two subdivisions. First one is ray optics, also known by the name geometrical optics. Now ray optics means light is considered as a ray, mainly concerned with the particle nature. Here light is considered to be a particle and light travels in a straight line. You have studied the term rectilinear propagation of light in your lower class, isn't it? Which means light travels in a straight line. So ray optics is mainly concerned with particle nature of light and also based on rectilinear propagation of light. And it also it explains the phenomena using laws of reflection and laws of refraction. And the second subdivision of optics is wave optics or physical optics. Now there are certain phenomena which occur in our nature which scientists were not able to explain using the concept of ray optics. Very simple example is during rainy season, you must have seen the potholes in the roads will be filled with water and oil will be floating on the surface of the water, isn't it? And this oil will have different colors. Now this is due to a phenomenon known as interference. And using ray optics, scientists were not able to explain why interference happened. And also if you are wearing coolers, you know what is a cooler, isn't it? Sunglass. You feel less intensity of light falling into your eye. Why? Because something in the cooler is cutting or blocking some rays of light to pass through the coolers, and it is known by the name polarization. This phenomena was also not able to explain using ray optics. So a second branch of optics was discovered, and it's known by the name wave optics or physical optics, and it is mainly concerned with wave nature of light. Here light is considered to be a wave, not as a particle, and it is based on the phenomena like interference, diffraction and polarization of light. So in this chapter we are mainly going to deal with ray optics. Now we all know if light falls on a medium, means a transparent or a semi-transparent medium, there are three possible things can happen there. A part of light can be reflected by the second medium, a part of light can be absorbed by the medium, or a part of light will pass through the medium. So three different effects are taking place when light travels from one medium to another. First one is, if this is the incident ray, then a part of light will get reflected, a part of light may get absorbed by the medium depending upon the nature of medium on which the light is falling, and a part of light may pass through the medium. So reflection is happening, refraction is happening and absorption is happening. If you look into the diagram, this is the point where light is falling and a line is drawn perpendicular to this point with regard to the plane, and this is known as, that line is known as normal. So the angle between the normal and incident ray is the angle of incidence, and the angle between the refracted ray and the normal is known as angle of reflection. And you know angle of reflection is equal to, you will study angle of reflection is equal to angle of incidence. Okay, and then depending upon the medium, a part of light get refracted, it passes through the medium, and the angle between the normal and the refracted ray is known as the angle of refraction. So in this video we are going to study about refraction in detail. So what is refraction? Well, it is the phenomena of bending of light from its straight path when it passes obliquely, this word is very important, obliquely, from one transparent medium to another. The phenomena of bending of light from its straight path or bending of light from its path if the light falls at an angle, that is what we mean by obliquely, on the medium, then from one transparent medium to another. Now what happens if light is not falling obliquely but light is falling exact perpendicular at right angle to the medium? There won't be any bending of light, light will just pass through the second medium. Okay. And what results in refraction, or what is the cause of refraction? Imagine you guys are in a beach, okay? You guys are standing in the shore region and you are running. All on a sudden a wave came and you are running into the water. Definitely you will feel some decrease or variation in your speed as you enter the water from the shore region, isn't it? Same way, when light travels from one medium to another, there will be a variation in the speed of light, and this variation in speed results in refraction. If speed is more, then the ray will get refracted or move away from the normal, and if the speed is less, then the light ray will bend towards the normal. It all depends on the medium from which the light is coming and the medium to which the light is being refracted. Okay, and so the speed of light, there is a speed of variation in speed of light, and this variation in speed of light depends on optical density of the medium. Variation in speed of light depends on the optical density. We are familiar with the term density, but this density is not same as the mass density, mass by volume. This density depends on how much light is being absorbed by the medium and what is the variation in speed. So, optical density, the variation in speed of light depends on the optical density of the medium, and optical density is not similar to mass density. There is a variation. You can explain optical density either in terms of how much light is being absorbed by the new second medium or by the variation in speed. So, refraction is caused by the variation of speed of light when it travels from one medium to another. Laws of refraction. Now, imagine this is medium 1, this is medium 2. A ray is incident on medium, from medium 1 is incident on medium 2, then this is a normal, and here it is getting refracted. Okay. This is the angle of incidence, this is the angle of refraction. Now, the first law states that the incident ray, the refracted ray and normal to the point of incident all lie at the same plane. The incident ray, the refracted ray, incident ray, the refracted ray and the normal at the point of incidence lie along the same plane. This is first law. And second law is the sine, the ratio of sine of angle of incidence to the sine of angle of refraction for a given pair of medium is a constant. Ratio of sine of angle of incidence to the sine of angle of refraction is a constant for a given pair of medium, and that constant is known by the name refractive index, and the value of refractive index will be constant for each pair of medium, medium 1 and medium 2. Now, this law is also known by the name Snell's law of refraction. Now, refractive index is denoted by the letter either mu or small letter n. These are the two notations used to represent the refractive index of the medium. And based on speed of light, refractive index, you can define refractive index in terms of speed of light or in terms of wavelength of light. Now, in terms of speed of light, refractive index of a medium is defined as, so in terms of speed of light, refractive index of a medium is defined as ratio of speed of light in vacuum to the speed of light in the given medium. Ratio of speed of light in vacuum to the speed of light in given medium. Now, if we are finding the refractive index with respect to vacuum, if the first medium is vacuum, then the refractive index is also known by the name absolute refractive index. So, refractive index in terms of speed of light is defined as ratio of speed of light in vacuum to speed of light in the given medium. It can be water, glass, any transparent or semi-transparent medium. And if the first medium is vacuum, then it is known by the name absolute refractive index. Now, second the thing is relative refractive index. You know, relative means you are comparing it with two different mediums. So, relative refractive index of the medium with respect to medium 1 is defined as ratio of speed of light V1 in medium 1 to the speed of light V2 in medium 2, and it is denoted by mu 2 1. Now, mu 2 1 means ratio of refractive index of medium 2 with respect to medium 1. It can be also written as N21. Now, this is written as ratio of refractive index of medium 2 with respect to medium 1. Same way you can write refractive index as in this format also. It can be written as ratio of refractive index of medium 2 with respect to medium 1. It is given by V1 by V2 and it is known by the name relative refractive index. Now, we know the equation V is equal to mu lambda, where V is the velocity, mu is the frequency, and lambda is the wavelength. Now, depending upon the medium, velocity and wavelength will change, but frequency of the light wave will never change if the medium changes. Frequency depends on the source which produces the light. For example, sunlight. Sun is the source which is producing the light, and sun won't change, which means frequency of light coming from the sun will never change. Only the velocity of light will change, or the wavelength of light will change. So, we can define refractive index of the medium in terms of wavelength of light. I told you mu is equal to C by V if it is absolute refractive index, which means V nu into lambda of vacuum divided by nu into lambda of medium. Nu and nu will cancel. So, refractive index in terms of wavelength of light is wavelength of light in vacuum to wavelength of light in the given pair of medium. Now, what is the physical significance of refractive index, or why we are studying about refractive index? So, I told you refractive index is given by ratio of speed of light in medium 1 to ratio of speed of light in medium 2. If you found out the refractive index of a given medium in your experiment is greater than 1, that is, if nu is greater than 1, then what definitely we can say V1 is greater than V2, which means V1 means velocity of light in medium 1 and V2 means velocity of light in medium 2, which means light velocity is more, which means light is travelling from a rarer medium to a denser medium. Because why? Denser medium means optically denser, so speed of light will decrease, and if light travels from a rarer medium to a denser medium, what happens? It will bend towards the normal. So, angle of incidence will be greater than angle of refraction. If the value of refractive index is greater than 1, this much information you will get. You can say speed of light is more in first medium, which means first medium is a rarer medium. Definitely angle of incidence will be greater than angle of refraction. If the value of refractive index is less than 1, if mu is less than 1, then what happens? Mu is equal to V1 by V2, which means speed of light in medium 1 is less than speed of light in medium 2, which means medium 1 is a denser medium and medium 2 is a rarer medium. So, light is travelling from an optically denser medium to a optically rarer medium. So automatically what will happen? Speed of light will increase when it travels from a denser medium to a rarer medium. So what happens? The ray will move away from the normal. So angle of incidence will be less than angle of refraction. So if you get the value of refractive index, this much thing you can say. You can say whether it is the given medium is rarer or denser. The speed is more or less, whether light is bending away from the normal or towards the normal. So the physical significance of refractive index, it gives information about direction of bending of light, whether light is bending towards the normal or away from the normal. Also, it is related to the speed of light. So you can say whether light is traveling from a rarer medium or a denser medium, in which medium light is having more speed. I hope you got an idea about refractive index. Thank you.